Hello my dear students, let me welcome you on behalf of the EduSat sponsored program of the e-learning. On your today we are going to discuss about the nuclei 2, that means the nuclear physics, the second part we are going to be discussed. So, what we already discussed in the unit 1, those who are attended that class, they must recognized what are the definitions of its the particle, constituent particles, its representation, their notations and their terminologies we discussed there. And now, we will proceed about that chapter what are left. So, now take your the pen and the papers, be ready for yourself and remain in front of the screen at least for your the 55 minutes, then you will know something about your the nuclear physics nuclei of part 2. So, let me recapitulate what we have discussed yesterday. We first started what is the nuclear physics, and we know that no branch of the physics is discovered in overnight. So, we have written a chronological order of the development regarding your the nuclear physics. So, on that we came to know what are the constituent parts of the nucleus, and we have written it, that is your the nucleons, the protons, the neutron, the atomic number and their notations, how they to be represent, and what are the different classification of your the nuclei. About that classification we discussed about your the isotopes, isobar and your the isotons. And that isotope, isobar and your the isoton, those who are attending for the first time, isotope, isobar, isoton. So, in the isotope one thing is remain constant, that is your the proton number, that is your the Z, and the another two A and N to be your the vary. And for your the isobar, what you are remembering, that isobar having your the A to be your the constant, or the A is your the same, or you can write here this is your the same, this is your the different. So, for this one A and the remaining is your the N and your the Z to be your the different. And for your the isotons, what will happen? I said tone, tone means this is regarding for your the proton, this is regarding for your the mass number. So, A and your the Z being over, then what is remaining your the N, means here the proton number, this is your the proton number, it to be are the same, then what are the others to be are the different, that is your the P, Z and your the N. This is your the proton number, this is the neutron, proton number we have taken is your the small n. So, this is your the small n and this is the proton, that is your the small n. So, small n, this is the small n and this is your the A and your the N. So, these things we have taken on your the last class. So, today we are going to discuss about your the nuclear image. Nuclear image. So, what do we mean by your the image? When you are look for your the plane mirror, if you raise your the right hand, then it looks for your the left hand. If you raise your the left hand, it looks your the right hand. That is the characteristics of the plane mirror, you know. So, here also in your the nuclear, it has your the nucleus. Nucleus means it has your the proton and your the neutron. If the proton is your the P and the neutron is your the N, then that P plus N. So, if it will look through your the mirror, suppose this is your the mirror. So, this nucleus through this mirror, it just gives it the lateral sides to be or the changed, means the right to be or the left to be or the right. Suppose this nucleus, as I said, that is your the element is your the Z, this is your the proton and this is your the mass number and this is your the neutron. For the neutron we have taken that is your the n. This is also one type of your the representation of your the element. I said in the two types of the representation. One is which are the symbol followed by its the mass number. Second one with its the name followed by your the mass number, as I said in the nuclei one. So if a mirror to be the placed here, then the same element means when I am looking through the mirror, in that mirror only myself will be seen, not the other's face. So this x will be the x, but this neutron and your the proton numbers, that to be the change. If this is your the proton, that will be there. If this is the neutron, then this will be here. So in this case of your the nuclear image, it is that type of the characteristics of the nucleus in which there is a change of the proton to your the neutron and the outer the neutron to your the proton. Therefore it is called your the nuclear image. That is one type of its the example. So which one will be the example? To remember that example, please remember one of its the word, either your the on or your the no. And if it is the on means, O means your the oxygen, N means your the nitrogen. If you will remember by the no, then N is your the nitrogen, O is your the oxygen. And for the oxygen, that is your the O, and this is the 8, this is the 15. Another one is your the N, means your the nitrogen, that is the 7 with your the 15. And if a mirror to be there, as I said, then what will happen? This 8 means this is your the proton. This proton will be your the neutron, and this neutron will be your the proton. You see, if it is 0, 8, 15, you see, if this is oxygen, this is your the 8, this is your the 15, then what is the value of your the n? This value of the n here, that will be your the 7. Because proton and neutron addition will give you the mass number, p plus n, that will give you the mass number. So here this 7 means this must be your the 8. Are you clear, students? This is the 7, means 15 minus 7 will give you the neutron number. 15 minus 8 will give you the neutron number. So here the neutron number is the 7 and here the neutron number is the 8. So what it shows? The number of your the proton of your the first one will give you the number of the neutron in the second one. Similarly, the number of the neutron in the first one will give you the number of your the new protons of your the second one. You see this 8 of this position of the left, that gone to your the right. So if the mirror is there, right hand to be your the raised, through the mirror you will observe that automatically your left hand is raising. You see, this is your left side, this is the right side. If this is your the oxygen, I am looking or you are looking towards the oxygen, this is the right, this is the left. Through your the mirror, the left will be the right will be the left will be your the right. Left is your the 8, it becomes the 8 there, and this is your the 7, it becomes the 7 there. So this ON or NO, that is the example of your the nuclear image. These are the different types of the classification. And now we are going to discuss about here the atomic mass unit. That is your the atomic mass unit. So which is in small form is written as your the AMU, not that is the AMU, that will be pronounced as your the AMU, that is your the AMU, atomic mass unit. So if this is the atomic mass unit, means for the atom to find its the mass, what type of the unit is used, that is known as the atomic mass unit. And for this one, this atomic mass unit means it is defined as 1/12 mass of C612. 1/12 mass of your the C612 means carbon of your the C612, its mass 1/12 is taken as your the atomic mass unit. And you know that the 12 gram of carbon contains how many? 6.6 not to 3. Not means not NOT not. Here not is your the 0, which will have the KNOT not. There we are saying that the knotting means this is your the knot. So 6.023 10 to the power of 23 atoms. Therefore, we said that the 1/12th mass of your the C612. So in your the C you have your the this number of the atoms. Means if you will make it reverse, 6.023 into 10 to the power of 23 number of atom in C612 is 12 gram. So for the one number of the carbon atom is 12 by 6.023 into 10 to the power of 23 gram. And if for your the 1 unit, for 1 unit of which one? Now C612 of the 1/12th part. So for the 1/12th part, number of the atom of C612 is equals to 12 by 6.023 10 to the power of 23 into 12, because 1 gram the 12 gram contains of here the this one, this number of the 1. So 1/12 part means one number of contains or this much gram. So 1/12th part will contain here the this much of 1. Means this 12 will cancel. This is your the gram, means 1 by 6.023 into 10 to the power of 23 gram. This is your the 1/12th part contains of the this much of the gram. And if you will simplify it, that will be the 1.495 into 10 to the power of minus 24 gram. And if we make it in kg, that is 1.495 into 10 to the power of minus 27 kg. So 1/12th part, it is defined as 1/12th part mass of the this one, means 1 AMU is equals to that is equals to your the this much of the gram. If it is converted to your the gram, that will be the 1.660. So that 1.660 means 1.660 into 10 to the power 27. 1 AMU is equals to 1.660 of your into 10 to the power of minus 27 kg. This is your the 1 AMU. But as you know that for a proton mass is how much? I said on your the last class, that is 1.6724 into 10 to the power of minus 27 kg. And if this is equals to that one, then the mass of the proton in your the AMU, you see 1 AMU is equals to this much, and the mass of the proton is equals to this much of the kg. 1.6, this is the 60, 1.6, this is the 724. Means they are nearly same. This is 10 to the power minus 27, this is also 10 to the power minus 7. So this is also nearly your the 1 AMU. But for its the actual maintenance, that is the 1.007 of your the AMU. Instead of the AMU, you can write it as your the U. This is for your the proton. For your the neutron, the mass will be your the how much? 1.6749 into 10 to the power of minus 27 kg. That we written yesterday. So that is equals to your the 1 AMU approximately. You see, this is 1.660, this is 1.6749. So this is approximately of the 1 AMU, means this is equals to your the 1.008 of your the AMU, or you can write it that is equals to your the U. So the mass of the constituent particles of your the nucleus are, one is your the proton mass, that proton mass you can write as your the mp, this is your the neutron mass, you can symbolize as your the mn, and another constitution is your the electron, and what is the mass of the electron? That is equals to 9.1 into 10 to the power of minus 31 kg. You see, this is the 10 to the power of minus 27 kg, and this is equals to 10 to the power of minus 31 kg. Means this mass is very, very negligible in comparison to the proton and the neutron. Therefore, in case of the atom consists of electron, proton and here the neutron. This proton and neutron mass comparison with the electron is the very, very high. Therefore, this electron mass is gradually or the nearly to be the neglected. So, the total mass of the proton is nothing but the mass of the proton plus of the neutron. That plus of the neutron, proton and the neutron, that is its the atomic mass. But there is another term is atomic number. Okay, this atomic number purely it is a number, this atomic mass it is a mass. As we know that atomic number, it is only a number. That atomic number we are writing as your the A, and this is your the atomic mass, means the total mass which contains in your the nucleus. So, then what is the relation between your the atomic number and your the atomic mass? Relation between atomic mass and atomic number. So, what is your the atomic mass? It is the mass of protons plus mass of neutrons. So, mass of the proton, as we have written mass of the proton. So, mass of the proton means the number of a proton into the mass of a proton. So, mass of a proton we have taken as your the 1 AMU approximately, and the number of a proton if that is represented by your the Z as we have taken. Mass of the neutrons, neutrons means number of the neutrons. A neutron, what the mass it contains into the number of the neutrons. The number of neutrons is equals to your the A minus Z, and the mass of the neutron we have written as your the Mn. So, this is your the AMU of your the 1 AMU, because this is your the total number of the neutron into mass of a neutron. This is the total number of the proton into mass of the proton. So, 1 AMU is common. So, Z plus A minus Z of here the Z plus A minus Z of here the Mn means mass of the neutron, that is the 1 AMU, that is your into of the 1 AMU into of your the 1 AMU. So, Z, this is the number of the protons we have taken here the P. So, Z plus P of here the AMU. So, the atomic mass is equals to Z plus P into AMU. But what is your the Z plus P? Z plus P is your the A. So, atomic mass is equals to the mass number into your the AMU. This is your the very, very important relation in your the nuclear physics. As we came to know about your the nuclear size or the shape or the volume, at that case this application to be the taken place. So, this is the atomic mass. If the mass is there, then that mass will converted or measured in your the unit. So, next we will find what is the energy level of nucleus, or you can say that that is your the energy scale. that is the energy scale. Means in which unit generally your the nucleus to be the measure, and the common measurement is your the 1 eV, or that is called your the simply eV. eV means electron volt, and simply that is written as your the eV for the electron, E for the volt, that is the V. So what is your the eV? You know in your the electrostatic, and that is the amount of the energy eV. eV means for which it stands, you see, you know V is equals to W by Q. This formula you know for the potential. So V means your the potential. If that potential is the volt, W is your the work to be your the joule, and Q is your the charge to be near the coulomb. Means this volt into coulomb is equals to your the joule. So this volt for your the this V volt, and this coulomb for your the electron. Means for 1 electron the amount of the potential, amount of the energy which is required to go or the to cover through a potential difference of the 1 volt. To find the potential difference of the 1 volt by using an electron, the amount of energy which to be required, that is known as the electron volt. So one charge of the electron. So what is the charge of the electron? 1.6 into 10 to the power of minus 19 coulomb, and this is equals to your the volt. Volt means your the 1 V. For the one potential difference, for your the charge of the coulomb, charge of the electron, means this much of the coulomb to make the potential difference of the 1 volt, the energy which to be required. So if we make it combine, then that is 1.6 into 10 to the power of minus 19 CV. This coulomb into volt, the coulomb into volt is equals to the joule. So this CV will be your the joule. So 1 EV is equals to 1.6 into 10 to the power of minus 19 joule. Suppose I will ask one question, this joule for your the M case, then what will be the value of this energy in your the CGS? Are you answering? Please verify with your answer what I had already written. This much of your the arc. This is the joule. Joule in your the M case. If we will convert to the CGS, 1 joule is equals to your the 10 to the power of 7 org. Instead of the joule, if 10 to the power of 7 org to be the put 10 to the power of minus 19, 10 to the power of 7, that will the 10 to the power of minus 12 of your the joule will be replaced by your the org. So 1 EV is equals to this one. This is your the common unit of the energy level of your the nuclear physics. So in nuclear physics means for nuclear scale, the energy is your the 1 eV. But for your the that is for your the atomic scale, that is in it is for your the atomic scale, and for your the nuclear scale, that is equals to your the MEV, and for your the particle scale, that is your the GeV. So this M means your the million. Million means 10 to the power of 6 into 1 eV, and this giga means that is equals to 10 to the power of 9 into 1 eV. These are the energy levels which to be the measure in this scale. So here the question comes, if some mass is associated, and can what makes that mass? According to the mass Einstein's relation of the energy with its the mass, you know that energy is equals to mass into c square, and we have an expression how you will derive that one. So this energy is equals to mass into c square. Suppose the mass of an atom is 0.2 mu. Suppose the mass of an atom is the 0.2 mu. If its the mass is 0.2 mu, that 0.2 mu will be converted to your the energy. So that energy will be 0.2 is your the mass, into your the c square, though the mass is in your the a mu, that a mu, this is the c square, c means the velocity of the light, so that is equals to your the a mu into your the c square, 3 into 10 to the power of 8 meter per second, that square. But this a mu, though this is the meter per second square, this a mu to be converted into your the either in your the MKS or the CGS. But though this is your the MKS, not it is in your the MKS, it to be the converted into the MKS. So 1 a mu is how much we have written? 1 a mu is equals to 1.660 into 10 to the power of 27 kg. You see, today we have written 1 a mu is equals to this much. So 0.2 a mu means that will be the 0.2 into a mu is equals to 1.660 into 10 to the power of minus 27 kg into this square. This square means 9 into 10 to the power of 16 meter square by the second square. So these two be are the multiplied, that value of your the kg meter square by your the second square. So this is equals to your the, if the mass is equals to this much, then the energy will be the that much. So on that way you can find 1 a mu is equals to how much of your the EV or how much of your the MEV. In the same way you can find out. So 1 a mu means that 1 a mu to be converted into your the energy. So that energy is equals to mc square, means 1 a mu into c square will be your the 9 into 10 to the power of 16. That 1 a mu is equals to 1.660 10 to the power of minus 27 kg into this is equals to your the meter by second square, 9 into 10 to the power of 16 meter square by your the second square. And if you will take all these values, then that will be the 1.495 into 10 to the power of minus 23 of your the joule. And if that to be converted into your the EV, then 10 to the power of minus 23 by your the 1.67 into 10 to the power of your the minus 19 of your the EV. If we simplify that one, then that will be your the 931.5 of your the MEV. The question comes, sir, why you have divided with your the this much? So we have divided with the this much, that is equals to the 9.1 into of the this much, because 1 EV is equals to 1.6 into 10 to the power of minus 19 joule. So this is equals to the joule, means that will be the 1.6 into 10 to the power of 19 of the EV. So 1 AMU is equals to this much. After completion of the relation between your the mass number and the atomic mass, and how your the 1 AMU will be the 931.5 of your the MEV, now we will go for the intrinsic properties of your the nuclear physics. Intrinsic properties means inside the nucleus what type of the properties it exhibits, and one of that is nuclear size. Nuclear size means what is the size of the nucleus. Regarding that one, we know in your the nuclei 1 that the size of the nucleus is very small in comparison to that of the atom. As I said that where we are, if that one is a atom and its the nucleus will be a very small 0.1. If it is very small 0.1, means its size will be the very smaller one, and that size form is of nearly of the spherical, but not of the totally spherical, that we will discuss here now. So this is your the nuclear size. Suppose this is your the nucleus, whose charge is your the Zd, and according to Rutherford's alpha scattering, suppose one of the helium atom, this is your the helium atom. This helium atom is approaches towards your the nucleus. This is the helium, this is your the nucleus. So, the nucleus is the what type of the charge? That is the positive charge. And this is your the Andira atom, that is your the helium, He. He stands for the He means your the main. So, this helium is of your the two times of your the alpha particles. So, 2e. So, this helium we are writing for it is your the 2e. So, this is your the 2e and this is your the Ze. So, this E of the magnitude, they will give you the repulsion. So, though we have given the amount of the kinetic energy for its the scattering or for its the motion of your the alpha particle, it will move towards your the nucleus, though we have applied. But between them, there will be the electrostatic force of the repulsion. But we have given the force from the left to right. But due to the repulsion, what will happen? Through that energy, what displacement it would be, that will not your the continuing. Can I give you one of the example? Suppose you are in your the school or in your the day-to-day life, just you have given a pedal to your the cycle. What amount of the pedal you have provided the energy, according to that one your cycle must be move ahead. Suppose the cycle is not moving ahead, what you are guessing? Anyone is giving any force in its the opposite direction. Suppose the second example, you are making the cycle and going on over a road. At that time, the wind is just blowing in your the opposite direction. You are giving the pedaling, but the opposite side the wind is blowing. So, what amount of energy you are losing? Can you get that amount of the displacement is given by that cycle? Not, because they are in the opposite direction. So, here it will go or it will move with its the kinetic energy, and this kinetic energy will make it from left to right, but due to the repulsion that force will make it the in opposite one. So, this kinetic energy will gradually reduce, and this energy means this alpha particle will proceed up to a certain level where it will to be remain at the rest. Means this kinetic energy due to this repulsion will gradually reduce. So, if that reducing properties will continue, after some time it will come to your the rest. Means when it will come to your the rest, at that case this repulsion will be continue, therefore it to be makes its the direction to be the opposite way. Means if the alpha particle is going up to alpha particle is going from left to right, suppose at this position, this is your the alpha, it remains rest here, because this kinetic energy will gradually reduce, therefore this force will have its the influence. So, at that case it to be your the make it its the reverse. So, at that position, if the distance between them is taken by your the some symbol, say your the d, means this d is the closest approach distance. This is your the closest approach distance. So, here what happens? The kinetic energy now becomes its the potential energy, because it come to rest means it is at the rest position. So, due to that position the energy is the potential, due to the motion the energy is your the kinetic. So, here we have given the kinetic energy. When that kinetic energy becomes your the potential energy means Ek will be your the Ep. So, this is the Ep means what type of the potential energy? Electrostatic potential energy, and that electrostatic potential energy is how much? K Q1 Q2 by your the R or the R square, that is your the R, because this energy means your the work W is equals to your the Fs, F means your the force force is equals to K Q1 Q2 by R square. This is the S means the distance. That distance we have taken is the R. So this R will cancel. So that is the K Q1 Q2 by R. So you never thought that this will be the R square. It will be R square if that will be the force, but that is the energy. So EP will be the K Q1 Q2 by the R. So this K will be the K Q1 due to the one charge, that is equals to helium, that is equals to 2e. Q2 due to the nucleus, that is equals to the Jd by the R, but this R here we have taken as the D. So this will be the D, this will also be the D. So this is equals to the 1 by 4 pi epsilon 0 2 Z E square by the D. And this 2 with the 4 is cancelled. This is equals to Z E square by 2 pi epsilon 0 D. And if you will rearrange that one, then D is equals to, D will go there and Ek will come here. D is equals to Z square by 2 pi epsilon 0 Ek. So from this what it clears? It inversely proportional with its the kinetic energy, means with what energy we are just energizes the about to the helium 1. So if this energy to be the increase, then this distance to be the decrease. If the distance to be the decrease means this distance D to be the reduce, means the nuclear size to be the different. So this nuclear size and your the energy, they being your the related, and for your the different atomic nuclei, it observed that if R is that nuclear radius, that R is proportional to a to the power of 1 by 3. So the question comes, how sir R is proportional to a to the power of 1 by 3? So here it shows that the volume is proportional to its the mass, atomic mass, that is the mass, atomic mass. You can say that is your the atomic mass. So this volume will be the 4 by 3 pi RQ of its here the atomic mass. So atomic mass we have taken, suppose that is equals to the A of A mu. That is your the atomic mass. So from this we can say that the RQ is proportional to a to the power of 1 by 3. You see 4 by 3 it is a constant, pi is your the constant. So RQ, if constant into RQ proportional to your the A. Therefore RQ is also proportional to your the RQ. R is proportional to your the 1 by 3, RQ is proportional to A. So R is proportional to 1 by 3. So this R is proportional to 1 by 3 means this R will be the some constant a to the power of 1 by 3. You see R proportional to a to the power of 1 by 3 means R proportional to a to the power of 1 by 3 for the different nucleus it observed, means it is the experimental determination. So R is equals to some constant of that one, and that constant is your the R0, and that R0 is your the constant. That constant value of R0 is equals to 1.2 into 10 to the power of minus 15 meter. So this 1.2 10 to the power minus 15 meter means 1.2 10 to the power minus 15 is how much? That is equals to the femto. So that is your the FM. So R0 is equals to your the 1.2 of your the 10 to the power minus 15 means 1.2 of your the FM. So this R is equals to your the this one. So this shows that if here the A means your the atomic mass number, atomic number. If this atomic number to be the increase, then it's the radius to be the increase. So if we will go starting from the hydrogen, suppose we will go up to your the uranium. Here the atomic number, if it is the 1, and this is equals to your the 235. So for 235 the A, and that's power of 1 by 3. For your the hydrogen, that of your the 1 to the power of 1 by 3. So what you are observing? As the nucleus number to be or the increase, or the nucleons to be or the increase, then it's the nuclear size to be or the increase. But never thought that if that size or the increasing means it will look to your the naked eye, but that will not look for the naked eye. That is your the most concentrated matter of that one, and that size your the very very small one. You see that R0 is 10 to the power minus 15 meter. You just imagine 10 to the power minus 15 meter is how much. That is not your the much, that is your the very very less. So this is your the size of your the nucleus. So from that one we get the relation R is equals to R0 a to the power of 1 by 3. Next we will go for its the volume. Volume of nucleus. So volume of nucleus means volume is equals to the V. V is equals to 4 by 3 pi RQ, and that is equals to 4 by 3 pi R is equals to R0 a to the power of 1 by 3, that's Q. That implies is equals to 4 by 3 into R0 cube of your the A, and this 4 by 3 it is a constant. 22 by 7, this is the constant. R0, as we have written, this R0 is equals to your the 1.2 into 10 to the power of minus 15 meter. So this is also your the constant. This is your the constant. So we can say that the V proportional to your the A, means the volume is proportional to your the mass number. As we have written, the volume is proportional to its the atomic mass. This mass will be the mass number, means A of the A mu. So this V is proportional to your the A. So this is your the volume of your the nucleus. Next we will find what will be its the density. Next one is your the density of a nucleus. Density of a nucleus. So what is the formula of the density? The symbol of the density with your the, you can use by using a cloth, means that symbol is your the rho. So that rho is equals to your the mass by volume. The mass means whose mass? Nucleus. So this is your the nucleus mass by volume. Whose? Nucleus volume. So nucleus volume. So nucleus mass means the mass of the nucleus. What we have written? The mass of the nucleus will be the A of your the A mu. Are you clear to my point? Mass of the nucleus. Nucleus mass means the proton mass plus neutron mass. Proton mass Mn, neutron mass Mp of your the A mu. So proton mass Mn into A mu, proton mass, neutron mass Mn into A mu. So Mn plus Mp is equals to the A. So the A mu, that is equals to the nucleus mass. Are you clear to my students? Nucleus mass means the mass of a nucleus. What are inside the nucleus? Proton and neutron. So if the 2 protons, 3 neutrons, or the 3 neutrons, 4 protons, or the 1 proton, 2 neutrons are there, then their total mass will be the nucleus mass. So that nucleus mass by the nuclear volume. Density is equals to the mass by volume. So that is your the nuclear mass by your the nucleus volume. So nucleus mass will be your the A, capital A of your the A mu divided by nucleus volume. Volume of the nucleus. Volume of the nucleus is equals to your the 4 by 3 pi RQ. 4 by 3 pi RQ. So this is equals to A of your the A mu. So A mu by 4 by 3 pi R. R value is how much? R0 a to the power of 1 by 3. to the power of q, because rq, r is equals to r0 into a to the power of 1 by 3. So, that is equals to a mu by 4 by 3, 22 by 7, r0 cube a, and that a with this a is your the cancel. So, that is equals to a mu by of the this much, 1 a mu is equals to how much, 1.660 into 10 to the power of minus 27 kg divided by 4 by 3, 22 by 7, r0 is equals to how much, 1.2 into 10 to the power of minus 15 meter, that is q. So, that is equals to 1.660 10 to the power of minus 27 by 4 by 3 into 3.14 into 1.2 cube into 10 to the power of minus 45 kg by meter cube. So, this is your the kg by meter cube, because the density is the mass by volume. So, mass will be the kg, volume will be the meter, that is the meter cube. So, if you will simplify that one, then this will give you 2 into 10 to the power of 17, 2 into 10 to the power of 17 kg by your the meter cube. So, 2 into 10 to the power of 17, you just observe for the water, the density is your the 1000 kg by your the meter cube. For water, that is 1000 kg by meter cube, that is the density. So, that is equals to your the 10 to the power of 3 kg by meter cube. If this is 10 to the power of 3 kg by meter cube, but for your the nucleus, that is equals to 2 into 10 to the power of 17, 2 into 10 to the power of 17 kg by your the meter cube. So, if we will compare these two, so in comparison to your the water, the nucleus of your the any element which is independent of its the A, means either that is for your the hydrogen or for your the neon or for your the oxygen or for your the uranium or the thorium, whatever it may be. You see, the density never depends upon the A. Here the A is there, but now it becomes another A. So, this A is your the cancel. It never depends upon the number of protons or the number of the neutrons, but it depends upon your the its own value, means the density of the nucleus for almost of the all metals, that is your the 2 into 10 to the power 17, means in comparison to water, that is equals to 10 to the power 14 times greater. 10 to the power 14 times means how much, just you look over. Suppose we are applying a force on your the water, that water being your the displaced, means it changes the positions. But if you have a nucleus and just give you a blow, can you say that a nucleus will be the split? It will never to be the split. For that one, we have to give in the very high amount of the energy, and that energy though we have written, one is your the nucleus scale, one is the atomic scale, and one is your the particle scale. For the particle scale, the energy to be provided in your the giga electron volt. So, that much of the energy is required. So, if we plot a graph by taking the radial radius with its the density, the graph will be likewise. This is your the radial radius, this is its the origin, means when the radius is very small, then its the density will go up to your the 2 into 10 to the power 17, means it provides a maximum 1. Means when the radius is very small, means for the lighter nuclei, the density is your the this much, and as your the nuclear radius is gradually your the increases, that density is your the decreases. So when the density is decreases means your radius is your the increases, therefore we will say that the size of the nucleus is not completely your the spherical. As we go for your the higher elements means it's the radius to be the increase. For the higher elements the number of the protons and the neutrons are the more, so it's the nuclear force of interaction will be the more, so it's the radius to be the increase. Because as we observe that if this is your the helium and this is your the nucleus, if this nucleus have your the more number of the nucleons, then that repulsive force will be the more. So when the helium means the alpha particle will come and at the larger distance it to be the deflect. So when the distance to be the deflect means we will say that that influence is observing up to that point, and that is it's the closest approach which is considered as it's the radius. So as the radial distance will the gradually go on the increasing, the density will gradually decrease, but never you say that that is in comparison to that of the water. So we can say that the shape of the nucleus is not completely of the spherical. As we know that the shape of the earth, we are saying that that is the spherical in shape, but it is not the spherical. The shape of the earth is like of your the orange. If you will take the orange from your the distance, it will observe that it is a spherical, but when the orange will come near to it, you will find that the upper and the lower side of the orange is your the oval portion. So that is not your the completely spherical. Here also the size of the nucleus as the diagram we are taken, in every case we are taking it in your the spherical form, but it is not your the completely spherical. So these are the different intrinsic properties of the nucleus. So what are that intrinsic properties we came to know? One is it's the size, one is it's the shape, one is it's the volume, and one is it's the density. So these are it's the intrinsic properties. By taking these intrinsic properties, there is a force exists inside your the nucleus, and that force is known as your the nuclear force. So before going to discuss the nuclear force, let us now make some silly questions regarding these nuclear properties. So the question number 1. 1 AMU is approximately the mass of which particle? Mass of the which particle? Suppose there are the 4 answers. One is your the positron, second one is your the proton, third one is your the helium, and the fourth one is your the nothing. Not means none of this. Can you guess it? Which one will be the correct? You see the positron. Positron means your the positive charge of an electron. So the charge is a positive, but what is its the mass? That of the electron. What is the electron mass? 9.1 into 10 to the power of minus 31 kg. And for your the helium, helium means your the He, He with your the 2,4. So it's the mass is nearly of your the 4 mu. Fourth one we have said that is the not. Then what is the remain the proton? What is the mass of the proton? That is the 1.007 mu. So there is a dilemma. Sir, the mass of the proton is 1.007 mu, but the question is 1 mu, but the question is not 1 mu. The question is 1 mu is approximately the mass. Therefore, this 1 mu and this one is approximately. So this is one of your the frequently asked questions. So with this we completed the intrinsic properties, and be ready yourself to go for your the nuclei third, in which we will discuss about your the nuclear force, and your the interesting one is your the radioactivity. Thank you very much.